Welcome everyone, go back our lesson. So today's lesson we will look more detail about the properties matrix tensor products. Yes, different from the last part. The last part is we focus on we focus on the tensor product, right? This part we will look about properties of matrix tensor product and how it's different. Okay, this part is one important lesson in the introduction of computing, quantum computing, and the programming. Yeah. Okay. Today's lesson is will look very quite easy if you already learned about the previous part. If we have a different computing, so the structure or the order is not important. Yeah. Over here is if you see. We have a three matrices, A, B, and C. Each the matrix have a different, the dimension. M, A, we have M and N, M columns and N the rows. No, M the rows and N the column. Vector B is have a P rows and the Q the columns. Vector C we have R the rows and S the columns. So when we multiply the three vector, so which one we do first? If we do this one first, right? We do this one is first. And after we have a result, we multiply with the other vector C. So we multiply this one as C is later, right? So it's equal to you do this one first, and after you multiply with A later. So the order is not important. Actually, this is one of very good property. Yeah, property. It's called associative. It's associative. Yeah. When we do which one, we have a computing in the three vector. We do which one first, and we do later. Doesn't matter. Okay, we have a same result. So that is reflect the associative property in the matrix tensor product. Yeah. Okay. And when we look more about the visual way. Yeah. If you see over here, we do the A, B first. I think so we do AB first. That means AB. We do this part first, and we this one. We do AB first, and we do C later. It's similar. We do 3-1 together. Yeah. So that is order is not important. So you can see we can do BC first and A later. Yeah. So. This kind of order, I remind you, okay, in the tensor product, you can compute the different computing structure, but they will have equivalent the value, okay, equivalent value. Yeah, you can see this equivalent value, okay, that is very important. And for example, when you can multiply the 2 or 4. This is 4. We see again the matrix size for this one. We have M, right? This This is M. This is N. So after we multiply, this one we have M multiply N, right? So total. But the vector U, this one we only have one dimension. Actually, we can say is the number column is equal to 1. Yeah. So after we multiply with the vector input U and V. So U and V. So this C, right? After we multiply, we have MN. Yeah. This kind of. Actually, this this indicate for this part, not only for U. Okay. If you see the point out is U. No, this one for total. Okay. Because sometimes it's a kind of, the figure like this, it makes misleading. But this one is for total, okay? Yeah. And okay, so if you see this mn and mn, so after we have the m multiply, maybe we have mn multiply 1. Yeah, so yeah, this one is after we multiply, we will remove this part. Okay, remove this part. We only keep this part and this part. So we have mn multiply 1. Yeah, that is the output vector. So now you similar. This one you do the A and B first and U and V later, and that you can combine together, right? So what about the you can A and U first? You can see if you A and U first, right? So you multiply this one, you can remove this part, right? So we have M1, right? Yeah, we have a same, yeah, right? So similar, we have B. So B, C, and this one you can write in the n multiply 1. So we have after multiply, so we're going to remove this part first. So we keep n and 1. So we have n 1, right? So after the final vector, yeah, the multiply to vector, you can multiply this one and this one. So you can have m n multiply 1, right? So if you compare this one together, you see the same, right? Same, yeah. That is the one that can tell you, okay, the order is not important. Yeah, it's not important. You change the order is not important. It's called the different. The computing, the model, still have equivalent the value. Yeah. Yeah. The different the computing structure, but equivalent value. Yes, we have do which one first. Doesn't matter. Okay. We can do A and B and U and V first. Which one is okay? So you can do this one later. That's fine. Yes, that's fine. Okay, that is one part. Actually, the most part only take about the the different the computing structure. But same the value or equivalent. A multi B, C, A, C, B, or equal to the A and B, C. Okay, this is kind of how the different computing structure, but we have a same or equivalent value. The order is not important. This one is multi, yeah, the same. Okay, that's it. I think the one property in the tensor product in matrix or in the quantum. Yeah, they have the same the method. Yeah, I hope you got the point in this lesson. Okay, thank you everyone.